Now moving on to the question 3 of data science assignment. So the question is explain the purpose of training, test and validation sets in machine learning. What is cross validation and how it differs from a simple trained validation test splits. So in this chart, you can see how to split a data set. So training set, that is a subset of data used to train a machine learning model. The test set is a subset of data used to evaluate the performance of a trained machine learning model on unseen examples, simulating real world data. And the validation set, this is the intermediate subset of data used during the model deployment process to fine tune hyperparameters. So the purpose of training, test, and validation sets is to train a model, tune its hyperparameters, and evaluate its final performance on unseen data respectively. Now, what's the purpose of training, test, and validation sets? So, as the training set is the subset of data which is used to train the machine learning model. So, the model learns patterns and relationships from this data. The validation set, as this set is used to tune the model's hyperparameters and to perform model selection, so it helps in preventing overfitting during the training phase. The test set, as this set is used to evaluate the final performance of the trained model on completely unseen data, so it provides an unbiased estimate of the model's generalization ability. Now we will look the what is the difference between cross validation and simple train validation test splits. So the simple split is the data set which is partitionized into three distinct sets. There's is training, validation, and test. Once typically with the fixed ratio, that is 80% of training, 10% of validation, and 10% of test. The model is trained on the training set, tuned on the validation set, and evaluated on the test set. Now, what is cross validation? So, this technique involves partitioning the data set into k equal folds. The process is repeated k times, that is k iterations. In each iteration, one fold is used as the validation test, and the remaining k minus folds are used for training. So the key difference is that cross validation is more robust and that is simple as its name provides, simple split. In cross validation, we have k folds, so k minus 1 times the training is performed, and in simple split, only one time the training is performed. Now you can look at this flowchart how the parameters are put into cross validation. The best parameters are checked and the model is retained, then sent for the final evaluation. And the data set is sent for training data and test data, and then it is sent for final evaluation. Now how it works? So in a common method, k-fold cross validation, the data set is split into k equal size partitions, that is k equal folds. The process is repeated k times, that is k iteration. In each iteration, one unique fold is used as the test or validation set, and the remaining k minus folds are combined to train the model. The performance metrics, that is accuracy, is recorded in each iteration, and the final reported performance is the average across the all cadence. Now, in this diagram, you can see how the k folds are performed. So first in first fold, the first we do test, and in rest of the k minus folds, we perform train. So this this all the training and after training and testing, the average performance of the data is calculated. So this is the process of k-fold cross validation. Now the difference from a simple test validation is that first is data usage, bias and variance, and third is in purpose. So a simple split uses each data point only in one specific role, that is train, validate, or test. In cross validation, every data point eventually gets used for both training and testing across different iterations. If we see for bias and variance, so a single random train validation test split can result in a performance estimate that is highly dependent on that specific random division. Cross validation reduces the variance by averaging the results over multiple splits, that is k-folds, providing a more reliable and less biased estimate of the model's true performance. Now, if we look for the performance of both, so the simple three-way split keeps the test set strictly separate for a final exam, and the cross validation is typically applied within the initial training data. Often, after a final holdout test set has been created to robustly tune hyperparameters and select the best model before using the final test set. So, this was all of question 3. Moving on to the question 4 in the next video. Thank you.